Okay, so I have one more thing I need to teach you before we can finally solve for these answers that what makes these polynomials become 0. Okay? So this theorem is the last thing that we're going to talk about, the rational root theorem. So guys, we're going to end up solving problems like this. All right? We want to figure out what makes this whole thing become 0. All right? And right now, we would just have to guess numbers. Right? And plug them in to see if they make 0. Literally have all of the numbers in the world. Those could be our answers. So that's kind of overwhelming. Imagine that you walk into a room because you left a bobby pin or an earring. Okay? And you ask me, Mr. Franchuk, where is it? I don't know where it is. And I say, well, it's somewhere in that corner. What have I done? Have I told you where it is? Not exactly, but what have I done? Somewhere to look, give you some direction about where to go. So the rational root theorem is that for solving these polynomials. It's not going to tell us the answers, but it's going to narrow it down from infinite numbers to maybe 10 or 15 or 20. So it'll narrow it down to tell us where to begin. Kind of like giving us a cheat sheet to how to do it. Okay? So let me show you how we're going to find these possible answers. The first thing you want to do when you look at these is look at the constant. What is my constant? 12 or negative 12. We're going to use plus or minus, so positive or negative. So the fact that it's a negative or a positive, I don't really care about for this theorem. All right? I just care about the number 12. What are factors of 12? 6 and 2, 3 and 4, 12 and 1. Very good. So watch how I write those numbers that you just said. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. How did I take those numbers and put them on this problem? In order from least to greatest. Very good, Bashir. All right? So that's the first thing you need to do. Notice all of them have a positive and a negative in front of it. All right, so it's not just 1, 2, 3, 4, 6, and 12. It's positive and negative of all those numbers. Okay? Now you take those numbers and you divide by the factors of the leading coefficient. Well, what is the leading coefficient? What's at the very beginning? There's nothing, so it is a 1. What are the factors of 1? Just 1. So you write plus or minus 1. Now if I take all those numbers on top, 1, 2, 3, 4, 6, and 12, and divide by 1, what do I get? 1, 2, 3, 4, 6, and 12. Awesome. So my possible answers are those that I circled in green. Am I saying that those are my answers? No, but that's where I'm going to begin to see if one of those is an answer. Okay? So this is kind of getting us ready to begin. Are there any questions about this so far? What if, I'm going to use this in red, so notice I'm going to make a little change here. So see if your brain can figure this out. I'm going to add a 2 at the very beginning. So would my numerator change? The numerator only comes from the 12. So did I do anything to the 12? No, so that stays the same. But now my leading coefficient is not 1, it's 2. What are the factors of 2? 1 and 2. So I don't just have plus or minus 1, I also have plus or minus 2. So watch how this changes things. Take all the numbers in the top, divide by 1. What happens? Nothing changes. But now you have to take all these numbers and also divide by 2. So what is 1 over 2? 1/2. So I have another root of 1/2. What about 2 over 2? Do I need to write 1? Why not? It's already there. It's already there. Okay? So 2 divided by 2, already there. What about 3 divided by 2? 3 divided by 2. Is that up there? No. So I need to write plus or minus 3/2. Or you could write the decimal of that, 1.5. What about 4 divided by 2? 2. That's already there. What about 6 divided by 2? Already there. 12 divided by 2? Already there. So this change of adding a 2 in front, changing my leading coefficient, added how many additional possible answers? Just 2. So we still have all of these that I circled, but we have 2 more, and they are fractions. So when you have a number in front that's not 1, expect to have a few that are fractions. Are there any questions about that? That was a little bit different. Yes? There could be. If I made this like a 6, what are the factors of 6? 3 and 2, and 1 and 6, right? So it'd be 1, 2, 3, and 6. So then you'll have a lot of fractions. Okay? Yes, Bashir. Why did I add the number 2? I just wanted to show you what happens when this is not a 1. I could have added any number I wanted. But that was a simple way to show you what happens. Right? So as Tiara said, it could be a 6, it could be a 3, it could be an 8, it could be anything. Well, you're not going to do that part. You're going to do one where it is 1 and one where it's 2. All right, that way you'll get to see the difference. Any other questions? Yes, Gavin. These top rows? Look at the last number, the constant. What are the factors of 12? 1, 12, 2 and 6, 3 and 4, and then I write them in order. Another check that I like to do is, what's 1 times 12? 6 times 2? 3 times 4? It's kind of cool, you got it. Yeah, Gia. I mean, okay. Are we ready?